Welcome everyone on this little session about biological and artificial intelligence. The idea of, as far as I understood from this session, is that actually it's not us presenting, but it's you giving us input and us all together discussing about what will be the next challenges and the next big thing in biological and artificial intelligence. So Mohsen and me, we prepared a very short presentation, but in the end it will be you that will have to give all the inputs. So indeed we need you. We have our ideas, but I'm sure that you have many more. So welcome. I will quickly introduce myself so that you know who you're talking to. My name is Fleur Zelderust. Yes, it's an impronounceable Dutch name. You can also just call me Flower. That's fine. I work at the Donders Institute at the Radboud University, and I am a computational neuroscientist, mainly investigating how basically network structure influences information processing. Next to that, I am leading SmartNet, a Marie Curie training network. So we're actually looking for PhD students. So this is a great platform, guys. If you want to come to any of our institutes, please come and join us. I'm also one of the board members of the Dutch version of the Brain Bee. We heard something about that this morning from Joseph. So I hope really that we can start working together with all the Brain Bees across Europe. And yeah, if you want to know more, this is my website. I will now give the floor to Mohsen.
So thank you very much, Flor. So here is Mohsen. I'm Mohsen Kaboli. Actually, I have two affiliations. I'm an assistant professor at Radboud University. Basically, I'm heading a group which is called Robotics Tactile Intelligence. And I'm also the senior research scientist and lead at BMW Group Research. There, I'm heading AI robotics group. Basically, which my activity is focused on bringing artificial intelligence to the robotics, and the robotics can be the classical robot, like a humanoid industrial robot, or the next generation of the vehicles. We're gonna have the autonomous vehicle in the future. And the interior of the vehicles can be considered as a part of the car, intelligent car, which requires multimodal human-machine interaction. And of course, in order to make, let's say, either robot or vehicle to be intelligent, we have to find out what is the basic of AIs from biology and how we can transfer it to the real physical system. So at the moment, I'm working on several projects. One of the projects is a Marie Curie funded project is Intuitive. As a PI, I have some PhD students. They are basically working on the tactile intelligence and predictive coding. And I navigate projects together with Tansu, Flor, and many other partners. There we are basically focusing on brain-inspired perception and learning for navigation and mobility. And at the BMW research department, basically working and focusing on the robotics and cognitive vehicle and cognitive interior. So this is basically about me. So Flor, so what is the next step?
So very quickly, I think we can give you a few hints of what we think is important in the relation between artificial intelligence and biological intelligence. But again, I mean the important point of today is that actually we don't give our ideas, but you give yours. So please use the chat window and the question and answer window as much as possible, and then we will try to lead a discussion about this topic. So I think we both have prepared like 2 slides about the relation between AI and biological intelligence. But after that, please, use the chat and the question window as much as possible, and we will try as much as possible to guide this discussion. I don't think we have the rights to invite people to talk, so I will basically speak for you. But yeah, please let yourselves be heard. And now I think Mohsen, you prepared these 2 slides, so go ahead.
Yeah, sure. So basically, before going to my slide, if you have any question, you can ask a question. There is an option here. You can send your questions here, and then other people can even vote. And the question which will get the most vote will be rated by either me or Flor. And also there will be another option, which is a poll. So we will also put some topics there. And if you will be interested, we can discuss about that topics. So now back to my slides. Actually, when I'm talking about artificial intelligence, basically with engineers, the first question is, what does intelligence means? How we can make a system intelligent and smart, and what are the applications? What does it mean? For example, how we can make or bring the artificial intelligence into the healthcare, or for example, when it comes to the mobility navigation, what does it mean? And even there are also some use cases for the artificial intelligence, machine learning in a business, right? So for example, when it comes to the data analytics and so on. So these are some, we have also made much more application and challenges. For example, one of them is the computation, which how we can, for example, have the efficient or less, how can we use less power in order to have the efficient computation, neuromorphic, event-based, for example, approach. Or now we are moving to the AI, quantum AI, or quantum machine learning. So if we go to the next slide.
Yes.
So in general, there are some topics I would like to maybe to share these challenges and topics with you, and to know, for example, how we can together find out some solution ideas in order to know how we can bring the AI to the real life. And the other thing is, again, as I said, when it comes to the when we want to industrialize the artificial intelligence, at the moment there are some uncertainty. For example, people they claim artificial intelligence is not safe, right? How we can make it safe, right? Safe means, for example, there are many methods. Let's say some state-of-the-art and common method like a deep learning neural networks, right? They are attackable, For example, easily you can make, you can fake the system and you can get, let's say, wrong result. Or we consider it as a black box, right? How we can explain, for example, if we have a neural network, deep learning, or any other method, the result we will get it. Always the result, the good performance is guaranteed. And if something happens inside, how we can describe it, how we can avoid kind of a surprise during the, for example, anyway, while we are using the AI, machine learning, and so on method in a system. Just short, I mean, one example, the last example from me, for example, when it comes to the autonomous driving, it's very scary. For example, if you will be in a vehicle, it can drive by itself, and everything basically is AI and data driven, because you don't know what's going on. You cannot really trust if there will be some, for example, if you will be in Autobahn, or if you, for example, for me, if I want to put my 2-year-old son in the car alone, is very scary, right? So how we can make sure AI, artificial intelligence, is safe, explainable, and trustable.
Okay, but maybe we can start with we cannot really do polls, unfortunately, because we don't have administrator, right? But maybe we can just use the chat for that. So maybe we can have a quick question. Who would use a self-driving car if it would go on the road right now? Please say so in the chat. And maybe afterwards we can discuss why or why not. So would you use a self-driving car? I think there's an interesting point here in the chat. It says only in prepared highways. Only after other people would use them. I think that's a fair point. You definitely might not want to be the first one using it. I would agree with that. But in prepared highways, I think is a fair point, right? I mean, as far as we know now, our AIs work well in well-prepared environments, but you know, environments where unexpected things happen. Well, you are partially at BMW, so you probably know better than I do. So how do your cars do these days in with unexpected events?
Actually, if you see now is a long time people are working on autonomous navigation and driving, and we don't have any at the moment, not at the BMW, in any other also the companies. There is no let's say the autonomous vehicle at the moment. One of the reason maybe not that maybe definitely is because at the moment we need to share, means if the autonomous car will be wants to drive in an autobahn, need to share the autobahn with us, you know, as a driver. And actually human is we cannot predict the human's behavior. Even if we will be able to, let's say, predict the environment, but prediction of the human's behavior is very, very difficult, right? This is one of the major challenges at the moment.
So you're saying that actually it's us humans, it's the biological intelligence that's too unpredictable for artificial intelligence to work with.
Comes to the, let's say when it comes to the collaboration, it's very difficult. But if we will have, for example, a well-controlled environment, you know, then of course this is possible. And the other thing is, even our environment, as you mentioned, is a dynamic. We have a lot of changes, right? So using the current method, you know, like a deep learning and so on, for the perception, for the sensory fusion and so on, requires too many data. You know, even if the vehicle will be able to drive, for example, in Munich, the city I am now, when you take the vehicle to another city in US, in Japan, is not the vehicle is not able to drive there because it's different environment, different rules, or let's say the conditions.
There's another interesting mention in the chat. Who's responsible in the case of failure? Is it the driver who's not driving? Is it the company or the programmer? I mean, and this is, I mean, of course, we're talking about cars now, but I suppose that's in general, the more the artificial intelligence is going to play a role in our daily life. I mean, it's a fair question. I mean, I'm not a lawyer, so I cannot comment on this, but maybe you do.
Actually, this is always a question, and I heard this question. I don't know, maybe 1,000 times, you know, but there is no clear answer for that one. But from, I mean, what I think, we don't want an intelligent system to make a mistake. Because when it comes to the biological AI, I think Flor knows better. So we make a mistake. But when we want to make a smart and intelligent system, the probability of making a mistake should be 0. Otherwise, there is no reason, you know, to have an intelligent artificial system.
Well, I would love to be able to drive to work in my car and then be able to read a book in the meantime. I mean, that sounds awesome to me.
So usually for me, again, I'm giving one example. So when if you consider calculator, this is the simple machine, right? So calculators are fast, right? Much more faster than human. But do you think you will use a calculator if it makes a mistake, even 99.999 everything is correct, but you will not use it, right? So we need a machine who is fast, smart, intelligent, and the probability of making a mistake and so on is really 0.
Yeah, I think Gaurang is giving a fair point here. He said the advantage of using an AI-based car is that it can navigate efficiently in traffic, for example, using Google Maps actively. And two, if a computer is driving, maybe I can use the phone or reply emails, etc. Yeah, that's for me also that would be one of the major. I mean, that's why I normally take the train and not a car, actually, because in the train I can actually do something else, and in a car I have to drive. But but of course there's some some nice stuff in a car. Maybe we can go on with the slides a little bit to get more towards the biological intelligence, and then continue this discussion, because I think it's very interesting. So I wanted actually to about how your presentation was how basically neuroscience or science maybe in general is influenced by AI, how AI plays a role in research, but it's actually also strongly the other way around. So I wanted to start actually with a very old picture that you see here. This was research actually from the 40s by McCullough and Pitts that first started making artificial neural networks, so to say. So they started with the very first neuron, quote unquote, which was basically a binary neuron. It sums its input until a threshold, and then it decides to fire or not. But this was the basis of it all, because around the same time, Donald Hebb formulated the first learning rule, so to say, and said that, well, the famous neurons that fire together wire together. And with that, he first formulated the idea that the memory in a neural system might be stored in the connections rather than in the neurons or or other places in the system. And that gave then way to the famous perceptron formulated by Rosenblatt and by Minsky and Papert in the 60s, where they say, okay, if you have neural systems that consist of multiple layers and then that have connections, you can actually do all kinds of computations. I mean, it was later shown that as long as if you follow certain rules, for instance, have nonlinear input-output functions, and you have several layers, that you can basically approximate every function. Which was complemented in the 80s by the famous error backpropagation by Rumelhart and Jan LeCun and Parker, which was then the learning rule for these perceptrons. And with that, actually, we have the foundations of a modern day AI. So this was all based on the brain. I mean, Hebb and was a neuroscientist, was a psychologist actually, and McCullough and Pitts really made their basic neurons on the basis of neurons. I mean, this was all started by neurons. The fact that it didn't become very popular until much later, that is basically 2012, that really first it was published in NIPS, that's the first big AlexNet that where they were able to train large convolutional networks for visual recognition. But that was because before we just simply did not have the computing power. So it was only until like 30 years later that we were actually able to use these rules, but the basis of it were made in the 40s, 60s, 80s. With this, I would like to add that AI is at the moment, of course, very it's having a big flight, and rightfully so. I mean, it's increasingly playing an important role in our lives, because it can all of a sudden make computers do all these things that they weren't able to do before. But I think there's still some points where our brains still outperform artificial brains, and that is on a few points. The first is energy consumption. I mean, if you calculate. I made a quick back of the envelope calculation the other day on how much, if you would, how much flops our brain makes, and then how much energy that would cost if you would use a desktop computer or a supercomputer. Well, you would need basically a couple of truckfuls of peanut butter sandwiches to be able to do what we do on a daily basis, which of course, how would you carry around a truckful of peanut butter sandwiches in your day-to-day life? That's pretty impossible. So the energy consumption of our brain is still, factors of hundreds or thousands better than that of the brain. Of course, we can also learn very fast. I mean, it's true that that of course that the AlphaGo can now play Go better than any humans. It can play chess and so on, but it needs millions of examples before a computer can recognize a cat in an image. I think many more than we need. We don't need to cross a street 50 times before we learn that things that come towards us at a very high speed is not something that you want to encounter. And we are much more flexible. So all these artificial intelligence are extremely good at doing one task, but you cannot ask AlphaGo to fry an egg for you. I mean, it doesn't have the interface, but I mean, our brain is extremely flexible in the task that it can be performed. I actually didn't realize until I made this presentation that there's now a film about AlphaGo. It's interesting to read. Anyway, why is the brain so much better in these things? We don't know. That's the simple question, but there's a few options that I would like to think about. First of all, our brain doesn't use error backpropagation. So maybe the learning algorithm, even though we didn't discover it yet, might be much better or very different from what artificial intelligence do. What neurons, the basic units, do is much more complicated than what a general convolutional network neuron is doing. So there might be something in the dendritic computation or otherwise the nonlinear input-output relations. Of course, our brain is much more recurrent than a general deep learning network, although I know that there's lots of research going on at the moment at making recurrent layers. So I'm very curious what will come out of that. And the fact that the brain uses spikes might play a role. I don't know. This is just questions that I have in my mind. And again, I mean, there might be some algorithms not only for learning but also for computation and predictions, predictive coding, reservoir computing that might be inspiring. That might be make algorithms in the end more efficient, more fast, or more flexible. Yeah, so that's basically my 50 cents to to this discussion. We have another half an hour, if I remember correctly, right?
Yes, sure.
Yeah. So let's see. Sorry, I have to switch screens if I present. I cannot. So I see here in a comment the advantage of using an AI-based car. Oh yeah, we already had that. So what do you think? What makes our brain better than an AI, or is our brain better than an AI? I mean, you're completely free to disagree with me here.
Sure. Or what do you, when we are talking about AI, Flor, we are just focusing on the brain. This is my question. AI is AI means brain computation, or when it comes to the AI as a system, we have to consider like a perception, multimodal perception, even not passive. We have to consider active, right? So means we should be, or any intelligence system should be able to select what is the best sensory information in a certain condition. Means, for example, when we have a vision and we have a tactile, if it's dark, we have to trust on tactile perception rather than vision, right? And what is the role of interaction, perception, interaction, learning, decision-making, control, semantic reasoning as a complete, not a complete, let's say the bidirectional domains, right? How we can formulate these, let's say, areas in one intelligence system? I don't know. I would like to know what people are thinking. Because for me, to be honest, as a system engineer, for me, for example, working on an AlphaGo is very nice, interesting. But for me, I would like the system moves. For example, a system can move into a dynamic environment, to interact with the people, to interact with environment, right, and make a decision. And if the decision is not right, can correct it.
Well, I don't know if you saw this this documentary. I was advised this documentary at Netflix the other day. It was called My Octopus Friend. And I saw that popping up in my Netflix, and I was like, I'm not going to watch an octopus for 1.5 hours. It's boring. But it was intriguing, and especially so because I don't know if you are aware of this, but the octopus actually doesn't have a brain, or it has a distributed brain. I mean, it doesn't have one central, brain thing, but each of its 8 legs can basically operate independently, and then somehow they work together, and sometimes they work independently. But they're extremely intelligent, right? I mean, they interact with people, they communicate, they and so on. So I'm always fascinated by this, is that we have this idea that, in order to be intelligent, you need a central nervous system. And then here you have the octopus that can recognize itself in a mirror and doesn't have a central nervous system. So I think that's fascinating. There's actually an interesting point here, is that says the brain might not use backpropagation, but it might use prediction error propagation. So functional wise, it could be similar. I think you have a very good point there. I cannot see, it's Pablo Lanios, I hope I pronounced that correctly. It's a very fair point, I think, because I think that somehow I really personally, and this is again one of the things that I believe but cannot quite prove, but I like the idea of predictive coding, of somehow presenting errors instead of representations itself. So in that sense, I completely agree with you that it might use prediction error propagation amongst amongst layers, amongst parts of the system. Yeah, and I think that there are some advances also in the predictive coding field. And yeah, but I don't know if there's, I mean, of course, there's people also developing learning rules for that. I think that there's a very important, it's also related to what you are saying, Mohsen, is that you have them to, it's of course very related to this active perception idea, is that you choose like what's in the, what part of the sensory information that we get is reliable at the moment and which is not, and then you choose to listen to one more than the other, then you get a bit in the Bayesian domain. Yeah, I think it's very interesting. I think that there's big things coming from there. There's also a new chat here. Mohsen, a question for you. We have neurons in the spinal cord. What about tactile system?
So in a tactile system, let's say the receptors we have 5 million tactile receptors. I think even Flor and Tansu, I don't know Tansu is there. I think they know better than me the tactile perception in humans. So we have multimodal tactile receptors in our skin. We have like 5 millions at least, so which they are working on a different frequency, and they are working in the different level of skins, and they are basically responsible for like a slow adapting, fast adapting, or and so on. However, when it comes to let's say the robotics, one of the main application or one of the main let's say one of the most important thing or like sensory information which is missing in the robotics is a tactile perception, tactile sensing, because when it comes to the sensation, we are at the moment in the robotics, we are not able even to grasp a soft object. We cannot manipulate like an object similar to dough, right? To make a pizza, for example. This is very hard. So these are the task means I think we are working more than 30 years, 40 years in robotics, but we are not even able to grasp a deformable object, to drink water, because the dynamic center of mass is changing, and we can get this information via our tactile receptor, right? And one thing I would like to also put it in a real system. We have camera as a visual sensory devices. We have also microphone to hear, for example, sound, but we don't have at the moment, after 20 years, any standard or common tactile sensor for systems, like robotics and so on.
I still want my Roomba to have whiskers. I think that would be great. That instead of like just bumping itself into the walls when it's vacuum cleaning my house, it would actually sense where the legs of my chair are, because now it always manages to get itself stuck, somewhere in my. So I always think like the Roomba could be so much smarter than it is right now, although it's of course great to have it. We have a new question.
Yeah, sure.
Do symbols a la GOFAI emerge in a sophisticated neural network? I think it's a very good question, because I know that if you train, for instance, a artificial neural network on natural images, then you get the receptive fields, so to speak, of the neurons in different layers become very similar to the ones that you actually see in the visual system of humans and animals. So the receptive fields of trained networks are neurons in trained networks are similar to the receptive fields in artificial networks. And also they show increasing levels of abstraction. That's also something that you see both in real systems and in artificial systems. And I think also in that sense, you start with something like edge detectors, and then you get something like corner detectors, and then what you get is more and more abstract, to the point where you get something that is, I think, similar to, gets a very symbolic value, so to say. I don't know if that's what you meant, Tim.
Flora, I have a question.
Yes.
Do you think if when we are talking about artificial system, do we need to consider like self-awareness and self-perception? If a system is an intelligent, means should know this is me, this is you, this is my hand, this is my door when it comes to the car, and what do you think? Or if someone here, I mean, in audience, audience knows about this topic, I'm happy to little bit discuss, because self-awareness, body perception, I think should be a part of intelligent system, right?
I think so. Yeah, I mean, it's a, but yeah. So you mean that if you have an intelligent agent that interacts with its environment, that it recognizes its own body as opposed to separate from the environment. I think it's yeah.
So, for example, when we are interacting, the human-machine interaction, human-robot, or human intelligent agent interaction, if I'm touching, and I'm talking, that person should know I'm talking with that person, or I'm touching that agent, and I'm touching, for example, the shoulder, or if you go, I think even some people can talk here, for example, when you go and you see yourself in the mirror, right? Especially like some animals, I don't like a monkey can recognize itself, right? So I don't know if someone has experienced this topic or did some research in this topic. I think I'm happy to also.
Yeah, I mean, Jem says even a simple Pac-Man program has a sense of self. My coordinates on the screen are X, Y. That is of course true, but if we, if you would think about a robot with a camera in its face, and it would look down and it would see its own shoes, would it be able to recognize that were its own, legs, feet, shoes, whatever you want to call it? Of course, there is a certain sense of self, obviously, because it knows that it's learning how to move in the space, and it knows that it's moving itself, and so on. I don't know if it's an emergent property. Maybe it's something that will just emerge once you get an interacting agent with the environment, that it learns at a certain point that if it looks down, that it always sees those 2 feet that are apparently its own. I can imagine that would happen. Let us go step by step. Yeah, it's. I had an interesting discussion the other day with a couple of my students in the context of brain organoids. So, as you might be aware, They are growing now from stem cells. They can grow in a test tube. You can grow little organs that then grow that develop themselves, and you can actually grow small brains from that get like a cortical structure and stuff. They really get some basic cortical properties and so on. The problem is, of course, and it's great because you can do well. It's just like test tube meat that doesn't need an animal to grow your steak. This is a test tube brain that you can do neuroscience on without having to take a brain from an animal, which is to a certain extent great. The question is, of course, when do ethics start to apply to these brain organoids? I mean, when does this little organoid become aware that it's like an organoid in a test tube? We're not there yet, but you can imagine that at a certain point, if you would let it grow enough, then that it would become aware that it's a brain in a test tube somehow. A self is only necessary if you have a body, a location, and adversaries, etc. Yes, I agree. But that's exactly what I think Mohsen was saying, right? That at a certain point, I think always a big example is, for instance, you have these little drones that that then fly over crops and then decide themselves where to fly and to see whether a crop, a field needs water or pesticides or fertilizer or whatever. So you have these drones that fly over fields and then themselves think, oh, maybe it's a bit yellow there, maybe I need to fly there to inspect that. So in that sense, we're not that far off, I think, of applications where we will have robots or agents that have a body, a location, and a goal. Do these things then need to have a sense of self? I think one of the questions that we haven't completely answered yet is, can we hope to integrate GOS, AI, and machine learning one day? Do you, Mohsen, do you have a comment on that?
If we will have, I believe that we will have an intelligent, let's say, the system or intelligent agent in the future. But the machine learning, of course, is a tool anyway to make it to enable the system to be intelligent. But I think if you would ask me when, I would tell you it takes a lot of time, because as I said, still in robotics, which I'm active in this domain, after 30 years, we don't have a robot can even grasp an object, and manipulate. There are a lot of works, but if you just, and everything is in the lab environment is well controlled, right? So if you see, for example, let's say in car industry, we have some robots there. They are just doing, let's say, pick and place, welding the body, But when it comes, for example, to close a screw, right? But still, humans has to use a screwdriver in order to go underneath of the vehicle to close it, or to put some, let's say, to assemble some interiors and so on, right? Or, for example, the simple thing, if you see even Amazon claims that they are using a lot of robots in order to make everything fast. They have automation, warehouse, and so on. But if you want to, for example, let's say load and unload shelves with the objects, thousands and thousands of humans are working there and doing a simple work, simple task. So I think it takes time. I don't know when. And I believe that maybe we need to really change our research direction, because when we are talking about artificial intelligence, I think we have to consider what does artificial intelligence means. We have to consider embodiment, If I'm able, for example, to manipulate this pen because I have such a hand, such a scheme, otherwise I cannot do that, right? Artificial means the intelligence, for me, is not only the brain, intelligence is distributed across entire body. For me, is like that, without considering many other, let's say, the aspects. We cannot have an intelligent system in the future. And there is another thing from my side: how much intelligent is enough? If you want to make a robot intelligent, you want to have it as you want the robot be as intelligent as 1-year-old child, or let's say 50-year-old an adult human. How much is enough?
Well, you don't want your robot to get bored.
But Flor, I was reading an article from Elon Musk, and he said if our system or robots in the future will be more intelligent than human, it's very expensive to keep human, or to, let's say, to have human. So if you look at the business, this is correct, right? From a business point of view. So then you
mean as an employer?
Yeah, it's for even there is, yeah, of course. Then if you have many, let's say, the smart system in the world, even I don't know if it's necessary to have many people in the world.
In the world, yeah. Well, I mean, I think as if you purely look at what goes in, what goes out, and how much flops are produced, I think humans are still a lot more efficient than most robots.
Yeah, this is correct. This is correct. But what about maybe in next 200 years?
Yeah, it might change. There's another question. There's an interesting potential ethical issue. We don't really know how consciousness arises in physical systems, and whether our type of consciousness is the only one possible. Then how can we be sure that, for instance, a neural net as big as GPT-3 or even my laptop is not already conscious, maybe suffering greatly but not able to say this? That's a very sad thought. Sorry, I have to laugh. My poor laptop being, forced to do MATLAB computations all the time. Sorry, I just had to laugh. No, but I think it's a fair point. I think we're going a bit into the philosophical domain, which is fine by me. But for me, it's all the question about consciousness is always a bit hard, because I've never heard a satisfactory definition of consciousness. I mean, I'm not sure whether consciousness is actually a thing or just an epiphenomenon that we think is a thing. Something that arises because we do certain computations and therefore we think we're conscious or something. But that's my opinion. I know that there's a lot of interesting consciousness research being done, which I'm not really an expert in, to be fair. The closest I came is that I once shared a lab with people doing consciousness research. So I heard quite a few presentations about it, and I remember that there was always the hard problem and the easy problem about consciousness. But it's a fair point. I mean, and I think that related to the point that I mentioned about these brain organoids, is that at what point does a system become so intelligent that it actually becomes aware of what it is, where it is, and what it's forced or not forced to do, which I think is a fair point, and we don't know. And we might, as our artificial systems, whether they are completely artificial or partially artificial, as in brain organoids, at a certain point, we will have to address this, I think, because if our artificial systems get so intelligent that, they start to have experiences, maybe we will have to. I think as far as suffering goes, I mean, I think our systems don't really have emotions or experiences, yet, but I mean they might get them. I mean, I wouldn't think that a laptop can suffer yet at the moment. Well, although my laptop sometimes says kernel panic, so apparently it is able to panic. But yeah, I mean, it's a fair point. At what point will we have to assess this? I don't know. What do you think?
Actually, this is a little bit difficult question. I'm considering my Roomba, my smart vacuum cleaner. I don't want. I mean, Roomba comes to me and says, "Oh, now I'm tired. I'm cleaning a lot day and night." You know. So, but I want my Roomba cleans. You know, if the robot realize let's say my flat, my house is dirty, but I'm expecting let's say my Roomba will be intelligent. Doesn't need to go everywhere, you know. If finds out, oh, some places is dirty, goes there and clean it, and then back to the charging place, right? This is my question. How much intelligent we would like to put in the system, right? In an agent, you know. This is really a question for me, and I don't know. If you have any opinion or any idea, I'm happy to hear it. And when it comes, for example, to the assistive robot or human-robot interaction for the elderly people, you know, how do you think? Do you want that person? I mean, the robot will tells you, oh, I'm tired, I want to rest, I want to, for example, I'm bored, I want to do something else, or 24 hours, 7 days take care of you, you know, and therefore you will not bother another human, right? So then you feel even better. What do you think?
So there's two comments here, I think, that are very interesting. One is saying, don't we already have intelligent systems in place? For instance, planes fly on autopilot, even and monorail, etc. And the other one is, it has to be a matter of degree of complexity. We don't worry about bacteria suffering, but we do about dolphins suffering. With respect to the second one, I agree. But the thing is that for a long time, for instance, I know that Descartes, for instance, thought that animals cannot suffer because they were kind of robots, right? For a long time, he said, oh, they're just these kind of clockwork-like machines, and only humans can suffer. And by now, we are, I think most of us are convinced of the fact that, you know, animals can actually suffer. I mean, I would agree that most of us think that bacteria cannot suffer, but then often the discussion goes, for instance, about pain receptors in the central nervous system. Oh, I get a question. What can we do for you? Maybe someone can take the floor because we cannot invite anyone to the stage. We are talking ourselves all the time. Maybe someone else would like to join the discussion. Anyone? I think Tim, you have been pretty pretty active in the chat. Maybe you would like to join us.
I think we have 3 active people. We can invite them to come here. Pablo, Semsei, and
Garan. Hello, welcome to the session.
Hello, my wife was worried that like I am not smart enough because I have my Star Trek T-shirt on, but
that's great.
Okay, so I'm a professor of computer engineering in Boğaziçi University, and but I am worrying about my laptop suffering because it may have arrived at this high level of complexity. And I don't know, would there be any possibility to think about that kind of thing in this Neurotech framework? Would there be some philosophers also working about such stuff?
I think that the neurotech in the end is what we make of it. So I mean, if you think that's important, then by all means start a group thinking about it. I don't see why not. So I think we're in such a startup phase that there's many possibilities to do many things. but I think that in general as a field we will have to to start thinking about this at a certain point. And of course, well, why I mentioned the octopus before, because I think that's one of the examples that for a long time, that was a distinction we made. Okay, if you have a central nervous system, you can suffer. If you don't have a central nervous system, then you don't have proper pain. And now we're slowly realizing that octopus is extremely intelligent, so is cuttlefish. Actually, trees have some form of pain receptors and stuff, so that it might not be that black and white. So like I said, I mean, I'm not a professional philosopher, so I mean, I'm always very careful with making great claims. But I think that our awareness of what suffering might be is evolving. And like that's why I also mentioned Descartes. I mean, he thought that animals, dogs and pigs were robots, and we now all agree that they can actually suffer. And I think that we're slowly starting to include octopus and cuttlefish as well. And at a certain point, it might be even more that we decide is actually capable of suffering.
Yeah, I mean, at some point, people will say that we should err on the side of caution. I mean, who knows? Like GPT-5 is too big, something like that.
So let's see who else is joining. Are there? I don't see. There were more people joining the talk, but I don't see them yet. I hear they are hiding. I hear someone say they are hiding. I'm not hiding because we have another half an hour or so. I think I think it is a great, but it's a great discussion, and I think it's also this might be the right place to. Samira couldn't join. That's a okay.
Oh,
there's some technical issues. We are actually indeed with around 1,000 people across the sessions and the main event. Then that's a lot of. I think that might be one of the biggest events on this platform so far. I mean, I've used Crowdcast a lot, and it's great. But this might be on a new scale of things. It's
so I would like to ask something. There is, since I don't know the latest status of it, maybe you could enlighten me. There is this European brain project as well, right? I mean, people are trying to map a little slice of the brain, and it would be meaningful to somehow connect these so that we have some idea about how intelligence works and what are these things compatible right now? I mean, what we know about all this stuff.
Welcome, Gaurang. Great that you are here too.
Hi.
You mean the Human Brain Project, right?
Yeah.
So in principle, this is a separate project. It's a European flagship project. Also, as far as I know, I mean, I have quite a few friends and colleagues working for the Human Brain Project. They are, even though they don't always claim to be, they are more of an infrastructure project in that sense that they are developing an infrastructure for people to, for instance, share models and data, the biological data, across platforms, across animals, across modules and so on, so that we can eventually create a model of a brain. Indeed, that's the goal. But they're in that sense, they're more trying to facilitate integration of things that are already going on than that they are basically developing one giant mother model. Gaurang, do you have experience with the Human Brain Project?
No, not at all.
No,
sorry.
no worries.
But I just had one question, and hello, Sin, again. So in terms of what you were saying, whether the AI is 1 day old or 50 years old, does that really matter over here? Because take the example of basically the way planes fly on autopilot. That is obviously the golden or the benchmark over here. So would those kind of factors really matter?
Wilson, I think that's for you.
Should I repeat the question?
I didn't get the question because the connection, your voice was not clear. I didn't catch the question.
So in terms of the AI, so we already have quite a lot of programs by which planes can fly on autopilot and many other monorails, etc. So does the age of AI really matters when it's trying to decide how old it is? So in your talk earlier, you were saying whether do we want a 1-day-old AI or do we want a 50-year-old AI? Does that really matters?
The examples are very interesting. We have at the moment automated systems, but we don't want to have again another automated system. We want to move from automation to autonomous. And autonomy means a system, for me, can perceive, let's say, the information from the environment by itself, can interact in order to refine it, can learn by itself, can make a decision by itself, and also can control by itself. This is, for me, if I want to have an intelligent system, the intelligent system should have these capabilities and abilities. But the autopilot is automated, is automation, right? Everything is fixed, right? But the airplane cannot perceive by itself. So no, for example, now it's cloudy, I want to switch to radar, right? Or I want to go to the LiDAR, or I want to do this one, that one. These are the automated system, right? And they don't have any, let's say, the autonomy. And when we talk about artificial intelligence, we are also considering the cognitive system as well, right? When I don't know, there was some in the chat, some discussion related to the humans, dolphin, and so on. Of course, they have different level of cognition, right? So when it comes to the AI, we will have different level of autonomy. So for example, this is the smartphone, right? But for me, this is not a smart, right? This is not intelligent, right? Because it's a camera and it cannot do anything. But we call it a smartphone, right? Because even when it comes to, let's say, the perception, cannot get information by itself, right? And if you are touching, it cannot touch you back and tell you, oh, look, for example, go to this side is better, right? So this is very important for me, or not for me, I think, for the system, how the system can be autonomous and how much autonomy will be enough, right?
Yeah, thank you for the answer.
You're welcome. So,
welcome, Sumira. Do I pronounce that correctly?
Yes, pretty correctly. Hi, everyone. I'm really happy today I could join you. I don't know how did I get the invitation. I really don't know. But I'm really, really happy that I could join. I'm a master student in Istanbul University, Cerrahpaşa, Electrical and Electronics Engineering. And I am about to prepare my thesis. So this gave me a lot of opinions. What should I do? So I wonder, how can I work with your community?
With our community?
Yes, Neurotruck and NeurotechEU, because I looked your website, but I couldn't see any join or application form. So can you inform me about this?
Gavan, you might be able to enlighten us.
So what I can do is I can give you the address, my email address, but then in any case, every university has basically a certain few student contact points. So it's actually Mert Polak from your university, and I'm just typing the email address of Mert. So if you want to join the NeurotechEU, then that's where you need to reach out. But if your question was more on how to do thesis, etc., then we have 3 good experts over here.
Okay, thank you very much.
So there is a comment here. That's the current phone. It's smarter than the old one. So I will just give you an okay, but for me it still is not smart. You know why? Because we just remove the mechanical buttons, you know, with, let's say, the digital one. Still I'm using my finger, I'm touching, you know. Now we are using a touch screen, is, let's say, the capacitive sensors, and before we were using the mechanical one. Where is, what does it mean? Means, is it smart?
Oh, but come on, it's obviously has a lot of smart features that you would expect from a smart human. I mean, my phone actually reminds me about like invitations that came into my Gmail inbox like 6 days ago, and I have completely forgotten about, and suddenly whoop, my phone reminds me. I mean, I would call a person who did this smart, right? We are using the adjective in that sense. Of course, smarter would be even better, right?
Yeah. Actually, my question is, what does smart means? You know, if I'm smart, or if, for example, if this is a smart, how we can make it smarter, and then again more and more smart, means the before was stupid. But because this is a question, you know, because for me, still, when we are talking about something is smart, something is not smart, this is a still question, how we can say, let's say, a system is smart, because if it reminds you something or recommend you, this is a recommender system, right? It tells you, look, you should now take your tablet. Now, for example, looks at your facial expression, feels and can recognize, for example, you look sad, and offers you let's say, the happy music. Do you think this is a smart, or is, let's say, a system can let's say simply recognize something, you know? What does intelligent and smart means, you know, for us? Is enough if our system, for example, can be an assistive, means we have an assistive devices, and can be like, let's say, an assistant, or in the old version, our secretary, right?
I think, sorry, go ahead.
No, I think there's an important point in what you define as autonomous, is that you say, like, completely closing the loop, as in having a system truly interacting with its environment. I don't think we have any such system yet. It doesn't exist yet, and I think that is the real challenge: is having a continuous feedback loop between an agent and the environment, and that is, of course, what many biological systems are successfully doing. And what is the difference between an autopilot in an airplane, so to say, that it learned a couple of input-output relations, but it doesn't truly interact yet. It doesn't perturb its own system based on the input it gets, and it doesn't choose its sensors on the basis of the input it gets. So I think that might be a great challenge, and an interesting point.
Yeah, but let's remember that this is an ongoing project. I mean, it's artificial intelligence is in some sense like science fiction. Its definition is always changing, because like more and more things become real, and now they are no longer the topic of science fiction. So like, and that autopilot as well. I mean, you know, some years ago in Germany, a human pilot intentionally crashed the plane into some mountain or something like that. I mean, if that autopilot was, I mean, that autopilot that we are talking about right now is smarter and more intelligent, and like is a better person than that human pilot. If control was in that autopilot, then things would be better. So it's all a matter of really comparing with the previous version of the system.
True, but I mean, if we make a truly smart autopilot, maybe it will be, because it is truly interacting with its environment, maybe it will be unpredictable enough that sometimes it decides to crash itself into a mountain as well.
Well, yeah, in order to save like a million other people.
Maybe, yeah. I mean, we cannot ask the pilot anymore. Maybe he had a very good reason to crash himself into a mountain. We don't know.
And the pilot was smart, right?
But then
Well,
on the note of the sensing and autopilot, isn't it more like it is there, but it's really at its infancy? Because last year the Boeing had an issue with the MCAS system, wherein certain sensors came online, and then the computer just had quite a conflicting messages. So the computer didn't really know what to do. Or unless you are saying that would be classical not really AI system, but more like automation issue.
Yeah, and Flora, I think you know this better. Like in human, we have a region in our brain which is called amygdala, right? Is related to the fear. So means we don't want to hurt ourselves, right? Even if what will happen if our system will have similar, let's say, the region in their brain, right? And when it comes to the autonomous or intelligent system, they should be able to protect themselves, right?
there's another very interesting piece of research is that if you, there's experiments, for instance, with both humans and monkeys where they learn to really work with an artificial arm, like a prosthetic arm. But after a while, if they interact enough with it, they experience it as being enough as a part of themselves that they also, if you threaten to smash it with a hammer, it will have some kind of scared reaction, even though you could say, well, it probably cannot experience any pain from that prosthetic arm, but still it will almost feel that, and it will protect it if it can, because it feels as a part of itself. So yeah, I mean, in that sense, then if you would consider that to be suffering, then in that sense, maybe a computer could suffer as well if you would threaten its sensors or something like that.
Or means to protect this, protect it. For example, when it comes to, let's say this, the simple example, autonomous driving. If you are driving in a street and realize, oh, now there is a fire, you don't expect the car drives into the fire, right, and will burn.
Hope not.
Or explodes, right? So how, these are the questions still I personally don't have any answer for that. Means that the artificial intelligence is not only, let's say, a system can interact with the human, but can also protect itself, and therefore can protect even human as well.
But with the human that's inside the car, the human that's outside the car, which one has preference?
Yeah, good point.
These are also the question, because one of the area actually we are working at the BMW, which is quantum AI and quantum machine learning. Because at the moment, when it comes to the machine learning, artificial intelligence, everything is, let's say, is a logic, right? I'm trying to find the right word. Is rational, right? So, but what do you think, for example, if we will have, and if I'm not correct, just correct me, Flor. I think half of our brain are responsible for the rational decision, right? And the rest is like emotional and so on.
I don't know if you can even make that distinction. I'm not quite sure. That's I mean, things are only rational in context of in a certain context. So given that something will give you certain emotions, then a certain decision is rational. So I'm not even sure whether these two can be separated from one another.
So this one was again the question. This is again like a stereotype questions. If there will be like 3 people in left side and 1 person in right side, and if the car wanna, let's say, the crash, which side the car should decide, right? The 1 person, that person maybe is a 2-year-old kid, and let's say the 5 people there, they are, for example, an adult, right? So these are, I don't know, these are kind of questions we cannot at the moment answer. And maybe we don't have enough information, and when it comes to the decision making and control, we need to get much more information and to predict several steps ahead, right? So maybe we need some, let's say, something like a quantum computers, or I don't know, the system can predict many things at the same time, right? And therefore can find an optimum decision when it comes to the autonomous decision making. I don't know, for me still, when we talk about artificial intelligence, I don't want to make a system which is like human or similar to human or as intelligent as human.
There was a survey, I don't remember exactly when or which university made it. They were asking same question, autonomous, you are in a car, and there are some people, if you choose this way, you will kill one person, you will kill 3 persons on the other way. There were a variety of questions. Questions was a bit cruel. Because, I think they were trying to solve if people racist or I don't know, not rational. What would they choose? There were a lot of questions. One side has 2 old people, one side has 2 young people with baby. Which one you would choose? I felt like that was so crucial. And if artificial intelligence will learn from this, that's horrible, because people enters so many choices there, and we will teach artificial intelligence with that information, but so many people are racist in the world. So many people are not very rational. So that scares me at this point.
Mm-hmm. Yeah, and there is not unanimity about those irrational decisions either. I mean, in China, they say like the car should save the old person because old persons are more valuable, and in America it's the other way around. So it's not fair to want the car to be perfect in that regard, because there is no perfect answer. I would just expect the car to be better than like a drunk human driver. That would save lives.
Yeah, totally agree about that.
So what about the role of the people in the society? For example, if you have a same, 2 person with the same, let's say everything similar, but different social role. One is the president of US, not US, let's say some country in EU, and there is another person who doesn't have any, let's say the role, important role in a society. Then what do you think, Because for us at the moment, for example, we try to protect our chancellor in Germany, right? I think that person is more important than me. If they want to decide, they will kill. They want to kill me or my chancellor, our chancellor. They will kill me, right? So what about the machines? They have to do the same, or how they can realize it? Who is
the experiment that Sümeyra mentioned also had questions like that. I mean, on the left, there is a Nobel Prize winner, and on the right, there is a poor guy who lives in the street, and who would you kill? And it was a really disturbing thing.
Yes, it was very disturbing, because for me, I can't decide who is important. That's not up to me. That's too crucial. Even if I know some people is very bad, very, very bad, I can't decide to kill him. So if we feed the AI with these informations, and we will decide, and we will expect to AI should decide with these informations, it will react like as crucial as us.
So we will have to quickly wrap up. You can see it in the chat. I also got a text messages that we have a few minutes left. But I think these are very fair points, and I think maybe one of the conclusions from our workshop might be is that it's very important that if we start developing, new AIs that become truly smart, as Mohsen rightfully says, that truly start to interact with their environments, that we will need a strong ethical committee to think about these questions, and that the answers to these questions might not be the same everywhere, like you mentioned. I mean, different cultures have different ethics, right? and it might not be the one answer fits all. So your ethics module in your Chinese self-driving car might function differently than the ethics module in your Dutch self-driving car. I mean, I don't know, but I think these are very important questions, and rightfully so. And that's also, I mean, I'm a simple physicist / biologist, but I think that I mean, there's a reason why we come so quickly to ethical questions, because we are, we're getting slowly towards that, and it's important that we think about that. And let's please not. Let's please have some philosophers in that sense in the NeurotechEU. I think that's very, very important. Yeah, Bize, thank you also for being there. I think I'm not exactly sure how we go back to the main session.
We go automatically.
Oh, we go automatically. Okay, that's good. We have 3 minutes left. So does any of you have something pressing to mention before we go?
Very nice to meet you all.
Same here. I hope to interact much more with all of you. It was very inspiring to hear from all of you.
So the only thing from my side, when it comes to the artificial intelligence system, I believe that we need to inspire from biological systems and neuroscience to make intelligent system, but there is no need to copy. There is no need to make a brain like a human, because for me, always I love to fly, but I'm taking an airplane, and airplane is not flipping the wings, right? But it's inspired by biological system and birds.
I agree.
So from my side, thank you very much.
Thank you.
I really enjoyed discussion, and I hope we will have maybe the second and third and maybe the next workshops in this area.
Although it would be great if my Roomba could fry an egg for me as well. Wouldn't it? Thank you so much also for joining us at the stage. And I think it was a really inspiring discussion. Yeah, we go back to the main session. I will try to summarize what you all have said and what we have discussed here. Yeah, I think we will be sent back there any moment now. Yeah, and I hope to see so much more of you in the years to come. I think we have 20 years at least to interact. So that would be great. By then I will be an old and gray scientist here. Back in my day, when we thought these were smartphones.